Check, check, check. There we go. Looks like we've got audio now. Check, check, check. Hello. So let's see. If you're watching this now, maybe you could type hello into the chat box. So I'm Nathan Lively, and I'm in Minneapolis. So this is going to be a short live stream to just discuss system EQ for a few minutes. So I have this workshop coming up, and the workshop is in just 4 days. It starts on Sunday, and it's called How Do I EQ My Speakers? So if you're interested in that workshop, it is available on 3 different times on Sunday through Monday. So I'll put a link to that in the chat right now. So as I was preparing for this workshop, I realized that there are a lot of things that I wanted to talk about. EQ seems like the simple thing, but when I looked at it, I was like, oh, we need to talk about the goal of output EQ. We need to talk about when to do it, when in the process. I did a pre-test recently about this, and I noticed that a lot of people think you should do crossover alignment before you do your EQ. And initially that might make sense because you think, oh, well, I need everything aligned and then I'll do my EQ. But there's some problems with that, which we'll talk about at the workshop. Also, where do I insert it? Is it in the console? Is it in a subgroup? Is it in a master EQ? And then is it in a DSP? And then where in the DSP? Should I aim for a flat EQ curve? This is a big topic of contention. Every time I bring it up, I don't know, there's all this discussion about it, right? So we're going to get into looking at what types of targets you might want and for what different situations. What's the best mic position for EQ? So where do you put the microphone to EQ your sound system, to do your system EQ? How many microphone positions do you need? Do you need more than one? Where should you put it? How many? If it's more than one, then how many do you need to best characterize a sound system before you apply EQ? How do you identify problem frequencies? What are problem frequencies? And then where do you take action to make them sound better, to remedy them? And then how do you use EQ to control feedback in your sound system so you can get maximum gain before feedback without compromising on sound quality? How do you avoid EQing a comb filter? We have all these reflections coming in, causing combing, and other sources coming in, things that aren't arriving in time, they're causing a comb filter. How do we avoid accidentally EQing a comb filter? And then how do we do it quickly and get really good results? How do we choose the right shape of the filter? I asked this question. This is another question that people don't seem to agree on the answer for, right? There's a simple solution for this, but there's a lot of seeming disagreement about how you choose the right EQ shape. And then how closely should mains and fills be matched when you're measuring those? So we have all these questions, and if I open up, any of these bullet points, there's like many things under here that I would like to talk about. So as I was preparing for this, I was wondering, am I getting lost in the forest here? Am I not seeing the forest through the trees? So I started wondering, can I just talk about, before we get into all of these details, all of this technical stuff, all this minutia, talking about how audio analyzers work, what is time windowing, like how should we set things up, target, like there's all these things, right? Before we get into that, what is my framework? Like when I go out into the field, what do I focus on? Like what am I really doing? And I'm not sure if I'm satisfied with this yet, but I think these are the 3 main steps that I'm doing. Number 1, I'm doing some kind of close measurement. I'm not saying near field because near field and far field have specific definitions, but if I'm just somewhere close that has less reflections, what does that look like? And then once I get out into the audience, Then I start looking at speaker to speaker and speaker to room interactions. And then during the show, I continue measuring, right? So I think these are the three main things that I'm doing that I'll be talking about during the workshop. And so I thought I would just tell a little story today to get into this a little bit and help organize some of my own ideas about system EQ. So I would love to get your feedback about this. So please type your suggestions for me into the chat, type your questions for me into the chat. And if you're watching this after the live stream, please feel free to add some comments to this video about what your simple framework is. If you had to try to summarize your system tuning, system EQ process into just 2 or 3 steps, what would you tell someone else or what would you tell me to help summarize what you do? So let's look at a few measurements here. So I'm working at a church, and one of the first things I'm going to do is do some close measurements so I can just verify good behavior of these speakers. Are they doing what the manufacturer says they're supposed to do? So these speakers are already hung up in the air, but that doesn't mean you can't do it. If you are friends with me on Facebook, you've seen me post photos of going up on a lift, going up on a ladder, like whatever you need to do to get up there to measure them. Or ideally, you measure the speakers before they go up in the air, right? This is something that you could potentially do at the shop before you even put these up. So I'm measuring the speaker and I'm wondering, is this what it's supposed to do? How do I know? Is it supposed to be flat? Is it supposed to be some sort of tilt? I don't know. At this point, I'm just guessing. Well, I need some sort of comparison. Luckily, when I go to the manufacturer's website, I get this. I can download their GLL file. And this says, this is what we expect the speaker to do. Another place to look for this might be someplace like Tracebook. Maybe you guys know Tracebook is a new project I've been working on. And it is a place you can go to search for speakers and then open them up and take a look at the response. So you can get something similar to this, something that would be something more reflection-free, bordering on, anechoic, but we're not getting there. This is just actionable field data. That's what Tracebook is all about. So I'll put a link to Tracebook in the chat as well. Okay, so Tracebook is a good tool for this, and definitely the manufacturers. Unfortunately, well, I won't get into that. Okay, so just going down this path here. So we're looking for good behavior. So maybe I want to make a few changes here to have this response be a little bit more in line with this target that I've gotten from the manufacturer, right? So here are the choices that I made. I inserted, a few filters, and now I ended up being a little bit closer to the manufacturer's target. And here's the result. Now, I'm not up on the ladder and I'm not up on the lift listening to this, but at my position at front of house, I'm also just listening to see, do I hear any distortion? Do I like the sound? Is there anything that's bothering me? Do I hear anything rattling me? Do I hear anything rattling? Do I hear anything rattling? Because here's what I'm going to say, is that with each of these steps, I'm using all of the tools. I'm using all of my senses. I'm talking to my colleagues. I'm talking to the venue owner. I'm getting all of the information. I'm talking to the manufacturer. I'm getting information from them. So this is just one of the tools that I'm using. I hear people complain to me sometimes that maybe this is not a good tool and that it does not fully characterize the performance of a loudspeaker, or this is not really what we're hearing, blah, blah, blah. I don't think you have to worry about that too much if you use this as one of your tools, not the only tool. So we're not doing this, in some kind of a vacuum. We are in the room, we're hearing these changes, we're saying, I like the sound, and this is the measurement. Okay, so I'm going to move forward. I'm happy with this. And then I go on and do the rest of the speakers that way as well. Okay, so now I'm going to get into my second step of this simple framework. Far. Now, not far field, because that has a definition attached to it, but I'm just saying somewhere close, somewhere far. Now I'm getting into the audience. So now I'm going to start hearing this speaker that I measured interact with the room. What do I expect to happen there? Well, there's probably going to be some room gain, some sort of tilting of the spectrum where there's more low end and maybe a little less high end because of air loss. But I'm not very far away. In this case, I was probably only 10 or 20 feet away. So here's what happened when I measure in the room. I see, oh, this stays pretty much the same here. All that's happened is a little bit of room gain here. Let me turn on my screen mesh. So everything's pretty much the same here, and now we start to see this go up. Do I like that? Is that okay? Do I want to restore this, bring this down back to its response when we are close in? So this is totally up to you. Generally, as we move farther away from something, we also want it to sound like it's farther away. So if I am, 20 feet away from the speaker, I don't necessarily want it to sound like I am 1 meter away. Did I switch from using feet to meters? Sorry about that. If I'm 20 feet away from the speaker, I don't necessarily want it to sound like I'm 3 feet away. If I'm 100 feet away, I don't want it to necessarily sound like I'm 10 feet away. So as we're looking at these targets, we're always thinking about sonic image. How much sort of spectral tilt am I expecting as I move farther away? Am I inside? Am I outside? So all of these start to come into play in terms of what my expectation is for how this should sound and how this should measure. Now, how it should sound, now that happens automatically. So that's good for us, right? It's a little bit harder when there's not someone actually on stage, because you've probably noticed that changes, right? As soon as the show starts and there's people on stage moving around, it sounds different because we're like localizing into that and we're like, oh, this has actually changed a little bit maybe. Okay. So I'm trying not to get too far deep into the weeds here, but another tool that I use is that I have some just general targets for how I expect speakers to behave as I move farther and farther away from them and whether I'm inside or outside. So here are some targets that I might use. And I might look at this blue trice and I might say, oh, yeah, this is actually gaining low frequencies as I expect a speaker to behave as I move farther away from it like this. So it actually sounds fine to me, so I'm not going to do anything. So this was really cool, right? Because I did some measurements close in, and then I moved farther away, and it sounds fine. So it's measuring good for me, and it sounds fine, so I don't think I did anything at this point. So now I'm starting to measure my speaker to room interactions, and this is where I start. Oh, I actually did, oh yeah, because I forgot to look up here, right? Okay. So this is all looking fine. Let's go back to this as well. Even though I think even though the manufacturer was saying that this is the way the speaker performs, I decided that once I started listening to it, in the room and measuring in the room, that really I would like for this area to get boosted up a little bit. Okay, I wasn't liking that. So I tested out a filter in that area. Here's the response, here's the change. So I took this filter in and out and I said, oh, okay, yeah, it measures kind of like this, and I like the sound. Great, let's go with that. And then that ends up being my new target, or you could call this your gold trace or something like that. And then I sort of start to back off with the other filters. These act as the other filters, the other traces, right? The other targets. These act as sort of like a crutch, right? I'm getting into the room. I don't know what to expect. Maybe I've never measured these speakers before. I don't know, I just don't know what to expect. So I put on something like this so I can have some kind of comparison. But then once I get to a place where I'm liking it, I say, great, this sounds good to me. Let's just start using this as my target. So now I have something that's more appropriate. It's context appropriate, right? This speaker, this room, today, this is what's happening right now. Okay, so now I'm going to start adding in my other speakers. So we're talking about speaker to room interactions and speaker to speaker interactions. And then all of this is in respect to sonic image and whatever it is that is going to make me and my client happy. And again, using all my tools, right? So I'm listening, I'm asking my colleague, what do you think? Do you hear any problems? Stuff like that. So I start turning on the other speakers, and you notice that I've added in the sub, and I say, I think I like this. I think I hear a problem somewhere. Where is it? So I might go back to this target for a second, and I say, oh, maybe this is an area I need to take a look at. So I start playing around with a filter in this area, and I notice, oh, I actually like it if I can reduce this whole area a little bit. That seems to clean things up. So then I end up with this shape. And so then I can sort of like let this go away, and then maybe I let this go away, and now I have a target that is more appropriate to the entire system. I've turned the sub on. I see everything this way now. And I think that's as far as I'll go with this story, because I didn't actually get to measure this during a show, but that would be the next step in the process. So I've measured this. I have my show microphone placements. This is what it looks like at wherever I can put microphones, maybe just at front of house. This is what it measures like. Great. So then the show starts, and then who knows, due to changes in potentially like temperature, humidity, people in the room, I start seeing some changes in the response, and I can try to respond to those. So this is the simple framework that I'm trying to put together. This is how I want to introduce the topic of EQ at the workshop that I'm doing this weekend. Again, that workshop is how do I EQ my speakers? And it's happening on Sunday and Monday. There are 3 times. Hopefully you can find one that works for you. And I have the link in the chat if you'd like to take a look. Okay, so I think I saw a question come in from Tuan. Let me take a look at that. So Tuan says, are you measuring individual speakers and trying to match your overall target curve? Or, I can just move this window. Give me a second. Or match the individual speakers to the manufacturer's specs and then match to your target curve. So I guess it depends on whether I'm measuring close or far, Tuan. So remember, I'm starting kind of checking things out, and then just close in. Are the speakers behaving as I expect them to? So in that case, I'm looking at the manufacturer's specs, and hopefully they have some kind of trace that I can download and import into my audio analyzer and compare that to. So in this particular job that I worked on, there were 3 different kinds of speakers, no 4, and I had traces for 3 of them. And so I had those all prepared so that I could open that up, take my first measurements, and then say, okay, this is what the manufacturer says it should do. Here's what it's doing right now. It looks like it's well behaved, or maybe I want to insert a filter here and here to make it behave a little bit better compared to this target that I have. So yeah, I try to first just make them all kind of do what they're supposed to do close in. And then once I get to the second step here, then I might start doing something else to make them perform as they should in the audience, and make them match in the audience or combine in whatever way to achieve the result that I want in the audience. There's something else I wanted to say about that. There's other work that you can do here close in though. So in this case, let me find this other measurement 1 second. Sorry, these are kind of out of order. Sometimes they get mixed up for some reason. I have another target here. I think that's it. Even if this is not it, let's just pretend like this is it. So let me hide everything again. And let me just open that target again. I shouldn't have hid that one. Okay. So there's another measurement from the manufacturer, I think. I'm not 100% sure because I wasn't preparing to show you this. But when I put these two on top of each other, these are the two speakers I need to work with today. Like, they match pretty well, and they're basically just headed for a flat target. I guess what would be concerning, to answer your question a little bit more completely, what would be concerning is if I were working with two speakers that natively, from the manufacturer, were very different somehow. That's really uncommon. I don't think I've ever seen that in the magnitude, right? Because we're talking about EQ here. Now, in the phase trace, that's definitely something you need to look at as well. And you notice I'm not talking about the phase here at all because this is all kind of wackadoo. It's not really helpful, right? But in the frequency response here, in this magnitude graph, you generally see people kind of pursuing some kind of a flat trace or something, tilted up, because then it's going to couple with other speakers. But yeah, you want to look at these and see that they're not too different. So I hope that answers your question a little bit more, because yes, you also want them to behave well and probably match when you are close in, but I typically don't look at that until I get farther into the audience, right? So in this case, I think this was a left and right and then a center fill or a center speaker. And so I started getting out into the audience and it looked like this. And then I moved over to my center speaker and tried to basically make it match this response. Okay? So that was probably more information than you wanted. But hopefully that helped. Okay, looks like there's some other questions. Tuan has another question, or hey. Hey, I hope that's really your name. That's cool. Hey. If this was an array, would you measure the whole array or measure individual zones, since the array acts as a single point source? Hey, I have changed my thinking on this a little bit. I used to measure the individual zones, and now I typically measure it all together. So I'm going to open up something in the background, and then I'll show you something. Because when we're doing EQ here, it's really I have found it not super helpful to necessarily look at these zones in isolation, right? So imagine that we have an array like this, and we're going to put it into this audience. Let's look at it like this. By the way, this is just a demo template in Map 3D, so you could open this up as well. And this array is broken apart into these 4 zones. So here we've got, looks like the name of this got messed up, but this should be zone 1, right? Array zone 1. So we've got zone 1, zone 2, zone 3, zone 4. So Hay's question is, when I'm optimizing this, and I've got my 4 microphone positions, zone 1, zone 2, zone 3, zone 4, then do I mute these like this and look at zone 1, mute this, and then look at zone 2, mute this, and then EQ them individually? I don't do that anymore. I used to. I think that really only can be helpful when you have really big arrays where you have lots of isolation. But when you have smaller arrays, there's not much isolation, and I tend to just look at everything by itself. And I found that to be a lot. Did I say everything by itself? I tend to look at everything together. And then I'll look at each microphone position. So I might start with zone 1, look at that, decide if I'm happy with that. And in this case, I might be doing some zone EQ, but really just in the high end here where there is a little bit more isolation. And if I do some EQ and it doesn't change anything, then I don't do any EQ, because that'll happen sometimes. Sometimes you think you're adjusting one zone and nothing is changing because there's not enough isolation. There's too much overlap between zones. So let's take a quick look at this EQ. So you can see there's some slightly different EQ already between these zones. It's up here in the U shaping. So I think we're looking at zone 1. Yep. So if I were to make a big change here, let's just take this out, and then I go back to my measurement here. If nothing changed there, then the EQ is not working, and I can't really EQ by zone, so then I just move to EQing the entire array. But if there is some isolation, then I can sort of go through my zones here and try to get a more even matched response, my frequency response across the audience here. And I don't just have to, then I can get a little bit more granular. So your question is, do I measure the array as a whole or measure individual zones? So yeah, I typically measure the array as a whole, but I do look at those zones individually and then potentially see if I can EQ them. You have to just test it out. And it's a really easy thing to test, right? If you deploy your microphones and then you go over here and you start changing the EQ and nothing is changing, then it's not going to work. And you can just I just treat the entire thing as a whole. Okay, there's a question from Ayrton who says, is Open Sound Meter plus REW the ultimate freeware sound system alignment kit? So yeah, Open Sound Meter is great, REW is great, and it's really nice that we have free options in both of these categories of real-time measurements and non-real-time measurements, or real-time and offline, right? For those of you who are smart users, you're typically using a real-time measurement like this. You're doing measurements, you're making changes in real time, you're watching it move, that kind of stuff. If you are like an REW user, or what else, I'm sort of blanking on other ones right now, then you're typically making a measurement and then thinking about it or doing simulations on the measurement, and then measuring again to verify that those changes actually, took place the way you wanted them to. So is that the ultimate freeware sound system alignment kit? Maybe. I haven't used Open Sound Meter since its new updates, but I have some students who have used it in the field and like it a lot. I think the biggest thing, people ask me a lot of times, why would I use Smart if REW is free? Why do I pay for Crosslight? Why do I pay for FIR capture? Why do I pay for SatLive? Why do I pay for anything if we have a free option? I think the answer is pretty simple, because, and you guys will tell me if this is incorrect, but as far as I know, Rational Acoustics Smart is the only piece of software that can do multiple channels of real-time measurements and have an average on all at the same time. So if you want to measure 8 microphones all at the same time and look at an average of them in real time, you can do that in Smart. I don't know anywhere else where you can do that. So maybe there's other software you can do that, but that is the big, powerful feature for me. That way I can measure in several places at once, see what's going on, get a general idea, and then apply some kind of global solution like EQ, and then go back or continue seeing how it changes across the audience instead of needing to, take several measurements, then move the microphones back or something like that. Now in REW, you can now take several measurements at once, which is super cool because you could, deploy 8 microphones, take 8 impulse response measurements at once, and you could do 8 averages, so you can get really high quality measurements. But that's not real time. So if you are a fan of doing real time measurements and you want to do multiple channels, then you probably need Smart. But if you are a fan of doing offline measurements or non-real time measurements, then REW is great. But now I'm realizing that is a paid feature. I think it's $100. Totally worth it. I bought it as soon as it came out. It's super cool. Yeah, you can load up a bunch of channels with REW measurements. But yeah, thanks for mentioning that. So Hay says, how much averaging do you do when performing these tests? Moving the mic around in the area for more traces. Do you re-average after applying filters? So a few different questions there. How much averaging? I think the typical answer is 1 second if you're indoors, 3 seconds if you're outdoors. But I'll tell you guys that a lot of times I just leave it on infinite. Like, why not, you know? I just leave it on infinite, and then I just hit the V key over and over again anytime I need to reset it. Okay, so for me, the easy answer is just always go to infinite. Now, that doesn't work if you're doing something like aiming or you need some sort of quick response. But if you are doing tasks like frequency response and EQ, then yeah, why not use infinite? Then you always have, you know, maximum quality data in terms of averages. And then what was your other question? Moving the mic around in the area for more traces. Yeah, so I typically deploy 3 microphones. But there is some good research out there that says you should deploy more. So let me open that up for you because I had it open recently. Did I have it open recently? Let's see if we can. It's not here. Okay, give me 1 second. I think this is it. Okay, so hey, I recommend that you read this AES paper. There's a free version of it online. I can grab it for you right now, actually. Let me just move this out of the way so I don't accidentally reveal something embarrassing. I don't know what it would be, but I'm going to grab that for you right now. So, what is the best microphone position? Here's that link. Okay, so I'm putting this into the chat right now. That is a free paper, and it is super helpful. The main takeaway are two of the main takeaways are, number one, you need to use at least 8 microphone positions to avoid risk of making a bad EQ decision. That's 8. And number 2, you should use this kind of a configuration. Why? Because we cannot remove energetic first order reflections from our measurements with windowing. If none of that makes sense to you, then don't worry about it. The point is that if we want to reduce the risk of error with our EQ and therefore, you know, have higher quality, more consistent measurements, then we need to do more of them. And we need to space those positions around an area where the reflections are randomized, so they're not on top of each other. You know, if you have a bunch of measurements on top of each other, then you're going to end up with something on top of each other. So I actually have an example of that over here. So let me close this. Save changes. No. Let me open up MapXT. So here's a test of exactly that. Remember, well, where to go? So we're looking at this kind of thing. So I made, I did this in MapXT because it was easier to turn the walls on. And I just tried to draw out like a similar type of Z shape, zebra pattern here. And then I turned all the walls on. So if you're familiar with MapXT, you can do that here. You can see I only have one enabled right now. But I have all the walls on. And then I took all these measurements and then I exported them and imported them into Smart. And so here's what that looks like. Microphone 1, 2, 3. I want to draw your attention to something as I'm turning these on. Check out this area here. There's probably other areas where this happens. But this area here, look, there's kind of like two nulls, but they're in like different places, right? Here and here. And then there's another one kind of around that region. Okay? It turns out that this is consistent through many of these measurements. Let's see if it's in all of them. Not in all of them. It's consistent because it's from one of the walls, either the front wall or the back wall. And so it's pretty consistently in every measurement. And so then when you do an average of 8 measurements, then according to L-Acoustics, you've done the minimum to reduce your risk of making bad EQ decisions. And as you can see, there were so many measurements that had this null in it that made it into the average. Now, does that mean you're going to place an EQ filter right here, a tiny filter, and try and push this up? No, you're not, because you're looking at all these other ones and you can see like, oh, there's some kind of reflection that's cutting this here. I'm not going to be able to fix that with EQ. What you do is you look at the trend, right? So you see like, oh, this is stable. So if I don't like this, then this is a candidate for EQ. Okay? So yeah, in terms of how many microphone positions and where they should go, I definitely recommend you take a look at this paper. And the takeaway is basically, use this kind of zebra position, not this, and do at least 8 measurements, at least 2 meters away from the wall, and between 1/4 and 3/4 depth in the audience. Now at this point you might be wondering, but Nathan, you said you deploy 3 microphones. Well, that's because I want something that's a little bit faster in terms of repetitions. If I had 8 microphones, I would deploy all 8 microphones. Then I would take a measurement, change my EQ, take a measurement, change my EQ, take a measurement, change my EQ. Like, that's kind of my process. But if I only own 3 microphones, so I deploy those 3 microphones and then I run those over and over again. And that is prone to more error, and I'm just sort of aware of that. But to me, it seems like a better compromise. Otherwise, I would need to measure these 8 positions and then do my change and then measure these 8 positions again. That's not true if you're using, an M1, P1 kind of setup from L-Acoustics, because part of the L-Acoustics process is that you would take as many measurements as you want, and then you never have to take measurements again, because the entire process after that is all done virtually. It's all done within their, visualization system. And you could probably do the same thing in something like Crosslight or REW. You could take these measurements and then do everything virtually within the box, and then just decide, okay, here are my filters, deploy them, and I'm done. Maybe just listen to it and make sure it sounds okay. So that was probably way more information than you wanted, but you asked this question, so I decided it would be fun to get into it. All right, let me see if there's anything else. Oh, you said, do you re-average after applying filters? So yeah, my system that I'm using in the field currently is that I'm typically running 3 mics. You can see them here, A, B, and C, and then I have an average running at the same time. So I'll just start it up, play music, and then I'm constantly measuring. So I'm adjusting filters and measuring at the same time and just sort of trying to move quickly. Let's see, more questions. So Gerard says, I'm measuring with REW in my home cinema speakers. Is there a workaround to measure an Atmos configuration? REW provides only front left, center, front right, surround left and surround right, but not the height channels. I have no idea what that means, Gerard. I'm sorry. I don't know anything about home cinema. I don't know anything about Atmos. And I don't know what you mean by providing that REW provides these specific outputs. I don't know why you couldn't use REW or any other audio analyzer for that matter to measure any kind of multi-channel or single-channel, coherent, spatial, whatever system, because all these measurement platforms do is measure the data, they show you the data, and then you make decisions. So I don't really understand why any type of system setup would change that. You notice that L-Acoustics, you don't have a new measurement platform just because you have spatial audio. No. Same thing with Meyer Sound. You use your same Galaxy processor to do your sound system tuning for your coherent mono system as you do for your LCR, as you do for your spatial audio system. So it's all the same hardware and software, but I guess just a different process. So sorry I can't help you more about that question, but you might want to reach out to John Mulcahy, the creator of REW, about that question. All right, Harartan says, when doing spatial average, delay locator is only adjusted for the HF driver and not the sub, isn't it? Yeah, I mean, I think if I understand your question properly, Harartan, that would be handled automatically, right? Because the delay locator is always going to lock on to the high frequency peak. So here's something that I measured yesterday, and you can see that there's a peak here, and then there's some kind of reflection happening here. We can zoom in. And so, yeah, so if you have some kind of full range driver on, unless you are off axis from that driver, then the delay locator is always going to grab the peak. So yes, as I'm moving the microphones around, or imagine that I just have one microphone and I want to do all of these positions. So yes, place a microphone here, even if I have the entire system on, which it seems like what you're asking. Let's say that you have your main array on and your subwoofer on, great. So measure here, 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 and each time resetting the delay locator for maximum high quality data acquisition. Because if you don't, you're going to start getting drops in coherence, and you're not going to get as high quality data, because if you don't have the delay locator set correctly, then you don't have this nice situation. Okay, I'm getting too much into the weeds, sorry, but yes, resetting the delay locator. Okay, cool. So Gerard, it looks like someone else may have posted a solution there for you in the chat. Okay. I think those are all the questions. I was not what I expected. I thought I was just going to share this with you today. Okay, so let me just wrap up by saying that there's so much complexity here in audio, right? In acoustics, in electronics, hardware, software. There's all these things to know, but I'm attempting to kind of simplify this for myself and come up, with my own just sort of simple framework here to share with you, to say these are the main things that I'm doing. Verifying good behavior, verifying minimum spectral variance across the audience, and then trying to continue doing that during the show. Okay, thanks for joining me today, and yeah, let me know if you have any questions or suggestions.